Hello, everyone. Yes, good evening, and I hope you're having an amazing day. Today's our final class for Python for data engineering, and I really hope you've learned a lot. I hope you've been able to lots more to Python, right? But if you understand the simple flow of the simple flow of what we've been trying to pass across for the past three sections, then I believe you can keep on building up on that and learning your way through. Because I mean, we've had people with years and years of experience in this field. Learning doesn't stop, right? In the data engineering field, learning doesn't stop. It keeps going. You just have to learn the basic, get your foundation right, get the fundamentals right. Then you keep building up on what you've learned so far. So today, what I have prepared for us is a final workflow using Python to build an ETL pipeline, still based on what we did yesterday. But this one is going to wrap up. This workflow is going to wrap up everything we've handled, everything we've talked about from beginning of this Python class to as at yesterday. So we're going to see it end to end, how the workflow is being, how a proper workflow is being created. And I also implemented some best practice, best industry practice of handling pipelines and handling workflows. Okay. So I'm going to share my screen now, and it will be a short one, and I really hope you pay prompt attention. Not hope, you have to pay prompt attention, right? So, and if you have any question, always feel free to ask in the chat. My colleagues are always there. I also have an eye out on the comments because I really love when questions are asked in the comments. So I'm going to share my screen now, and we will start with what we have for today. Let me do this. So I hope you can see my screen. So we'll just continue with there. So this is the workflow we are going to take care of today. So just to cut across and give a brief summary, when we started with Python, the first thing we did was to look at the fundamentals of Python. In the case of fundamentals, we looked at the data types. I said Python has different data types that it works with. And if you understand the data type of Python, then you understand if you understand the various data types and how they work, then you can understand exactly how to structure your variables, how to store your variables, how to perform some calculations and do some manipulation. The most common one I listed was the string, and then anything that is in a text string data type, it has to be quote. Anything that comes as an integer, anything that comes as a whole number. We have the float, any variable that comes, any value that comes with a decimal, like 5.0, numbers like that. They are float data type. They are best stored in float data type. Because if you store your data type in the best format, again, you are going to get the best results out of that data once data is stored in the best format. Okay. Now, we also talked about handling files. I believe that was like one of the topics we reiterated on like over and over. I showed you different method of handling files, the normal method, using the read statement, and finally using pandas to easily read and, and transform your files from a data frame to CSV and from CSV back to data frame and so on and so forth. Then we looked at functions. I told you function is the best way to, you know, arrange block of codes in a way that can be reusable over and over again in the flow of your project, right? So all this that we've talked about, including even integrating into a database, working with database on Python, logging to be able to see the progress of your workflow, to be able to see what exactly is happening in your workflow, what is running in your pipeline, and so on and so forth. We are going to look at everything today as a joint workflow. So we're going to bring everything together, like we're going to create a full list of everything and see it as a whole. Everything first, we are going to create a CSV file that we're going to use for our workflow, because I want to also iterate over the fact of making a CSV, or rather making a data or writing data into a CSV. So one of the best practice working with, especially if you're working with Jupyter Notebook, not just Jupyter Notebook, even if you're coding on Visual Studio or whatnot, it is best practice to keep all your import statements at the beginning of your workflow, at the beginning of your project. It's like every single library you imported, they can even have a brief idea of what your project will be about. Because right now, if I should come onto this notebook and I'm seeing SQL Alchemy here, I know definitely there has to be a connection to a database here. And I know that there's either going to be a write to a database or a read to a database, and something along that line. So when you have things like this, when you arrange your import statement at the beginning of your project, it opens the ground for it to easily understand what the project is about, even if I'm coming to look at it from a third party view. Okay. So the three main important library we need for our workflow, we'll be using Pandas, because Pandas will be what we will use to work with our CSV file, we'll be used to create our CSV file, we'll be used to create our data frame, and we would also use it to manipulate data. I know yesterday we treated extensively different functions in Pandas that takes care of data. I'm talking of from renaming values, from renaming columns, handling duplicate values, taking out empty values, and so on and so forth. Pandas has it all. So we are using the Pandas library. I remember importing it as PD to make it short form to use over and over again during the course of the project. We import the logging library because we want to make use of the logging functions to give us real life log, and just a way to let us know exactly what is happening in real time. Then obviously our SQL Alchemy library, which I told you is like a bridge that connects a database to your Python interface and whatnot. So first thing first, let's create a CSV file. So I created a sample CSV file here. This is a list. Remember, I told you a very basic registration class. So different categories of a list, you can append to a list, you can remove from a list. A list is mutable, like you can change the values in the list without having to redefine the data frame. You can also perform calculation on the list, and that also depends on the type of data in the list. If you have list of numbers, obviously if you do a sum on that list, you can easily sum up all the numbers in the list. But if you have a list of text or string, you can't do a calculation on that number. So that's just by the way. I created some key value pairs to for each of the columns. So I have my column ID, column name, column amount, and column email. And I purposely manually made some of this data dirty. You can see right here that I didn't spoil amount properly. Also, you can see right here I put in some null value for email, just to make it intentional, right? So we'll be able to replicate replicate so we'll be able to try to see how it is in real life, right? So once we have that, then the next step was to convert it into a data frame. And I told you what converting to a data frame does. If you convert to a data frame, that's your variable. If you convert your variable to a data frame, you are giving it the attribute of a table, because pandas data frame is basically like a table. It comes in rows and column, and through that data frame you can you can use the pandas function on a data frame. You cannot apply a pandas function on a data frame without using .info. .info is part of the function of pandas. So if I want to do data.info, you see that this is going to show a null value. It's going to say the list all of the data. So you have to convert that data into a data frame. And once you convert it into a data frame, you can use the pandas function and that is the reason why we are writing. So we converted PD dot, we use the dot data frame function from pandas to convert data into data frame. And so it DF into a CSV, because we'll be using this CSV in the case of our workflow. We'll be using it to create our data frame we created, then using the pandas function dot to underscore CSV. And what's the parameter this function is? It takes in what is the CSV name that you want to create. In this case, we are creating CSV, and we are setting the index equals to false. I've told you the reason we set index equals to false because pandas data frame most especially, you can see even though the ID has 1 2 3 4, you can see all these 0 1 2 3, they are called index. They are the natural index that comes with data frame. So if you do not, when you're converting to a CSV, you're converting your pandas to a CSV, if you do not set index as false, these numbers, they are going to come with your CSV. And I'm sure you can see how messy it is going to be, because you're going to have an unknown column that just starts listeners that do not have any importance. It's always best practice to let pandas know that as it is converting this data frame to a CSV, it is not going to read attached index that comes with the data frame. So to just pick the normal columns and the normal values without the index. So that's the use of index equals when you are converting to a CSV. Now, because we want to use, I mentioned yesterday how to configure your login, but yesterday what we did was that we stored the values of our log. We stored it in a file called log, and that one is more standard practice because you will not be there to see the log in real time. So you want to come back to your pipeline and be able to see how it's run, right? So if I can now go back to that file, I can easily see all the steps that run in my pipeline. But for the sake of this class, and as we are here live, I actually want to see the results of the log in real time. So that's why in this configuration today, I'm taking out the parameter file name. So I'm not saving the log into file. It's just going to return it in real life. Like I'm going to be able to see the output of the logs in real time. That's what I meant. So I already explained to you, if you set your login info, we are not but so don't complete for your login will be .info. You won't be able to access .debug because .debug is lower in hierarchy than .info. So if you should set your login.info, meaning you're only going to pick all the level of login from info and upwards, which will be from info, you have the .error, you have the .warning, and that's it. But you won't have .debug. So if you know that you want to still make use of your debug in your stuff, you want to overwrite it, you can start setting, configuring your login lowest to be, but that's outside of the scope of this class. Now, the reason why I set the format is because the way I want the log to return back to me, I want the format to give me the time, the level name, and the message that it is trying to return to me, the log message I want to see. Right now, for this workflow, this was the one we worked on yesterday, and as you can see, this is quite, if I'm working this type of scenario, if I might cry because a lot is not advisable. This is not the standard workflow. Now, what it is to show you a standard workflow of how things are done on production level. It is best practice that, okay, if you know that, oh, you'll be having to use a column, use a function over and over again. If not, you'll be performing a task over and over again. It is best practice to put that into a function So you can just call that function and get your task done. So you won't need to start writing all the flow from A to Z. You're just going to define everything in a particular function because it's easy to work with functions. With a function, you just call out the function name, pass the parameters, and that's it. Right? It is much more easier to work with a function than to start writing tags. So based on the workflow we did yesterday, what I prepared today was that I picked out some of the common functions that we did yesterday. I know yesterday we standardized the value. In this case, we converted to uppercase, we converted to lowercase and whatnot. So based on that, I created a function called function. Where the function is a def with function will accept. This is the parameter that I'm saying that okay, whenever you're calling standardized value, you need to provide the data frame you're working with and the column you're working with. That is all you need to do. But now I've already defined it that whenever I provide the data frame and the column, those two things, it is going to automatically convert case and it will return the column of that data frame in uppercase. So that's what this function is going to do. So if I would need to use this function, what I'll do is just to call it. I'll call the name, standardized values, and let's say my df is df sample. That's my data frame I'm using is df sample, and the column I want to standardize is, let's say, name. So if I should just call this function this way, it is going to return data frame with the name column, everything in uppercase, right? That is what it's going to do. So it's a very good practice. If I want to also use the same function again on another data frame, I would just call it out the same way. Just write out the data frame to be worked on and put in the column. You can see in one single line, it should do a syntax error when you're trying to recall. We are trying to recall the function message and whatnot. Name is not defined, not a small n. Defined in capital N, not small n. So you can see the output. It returns a value column. It is much more easy because I'm just going to call out function name, put in the data frame I'm working on, and put in the column to be worked on, and to give me my results immediately. And based on this, it is not only limited to just this project alone. If I have another project and this function is available on the project directory, I can also make use of this function in my project to perform to standardize the column. Example we gave right here, where we tried to work on the name column, but we found out that the name is actually starting with a capital N instead of it to be in the same casing. And actually best practice to store your as lowercase instead of uppercase. What data frame, right? Then all the columns in that data frame, it is going to convert it to lowercase. So that is why we have df dot columns dot lowercase. So if I should call out this function, put in any data frame, it doesn't matter what the type of column it is named as, it is going to convert that column names. Everything will be converted to lowercase. So created. Now we also worked on converting data type, because remember that the amount data type, it mostly came with floats, which was not sustainable because we didn't need that to be in floats. We convert it properly to integer. And as I'm saying that, what if also, but in this case, the way the function is that it is going to take in a parameter called x, and it is going to set a default value to be 0. So what this means is that anytime it tries to convert that integer to once it tries to confirm the data type to x to integer, if the data type is actually not stored as integer, like if the actual value in that data is not stored as an integer, it is going to just simply convert it to 0. And it is a very important function, the fact that if you are trying to convert, let's say you have a list of numbers, but within that list of numbers there's a human error and somebody typed in like a name part of those list of numbers, obviously a name is not meant to be there in the list of numbers. So what it will simply do is to convert that type to 0, and it is still going to return the data type of integer. So that's what this function is going to do. Now the next function we also worked on yesterday, we tried to remove duplicate values. Now, based on everything we did in our column, we will just simply call out the call function remove duplicates and the parameters. What are the parameters? Data frame. So in this case, I guess our data frame is called df sample. Then the column to remove duplicates from, let's say, id column. So we just call out this one single line like this. Perform every good check, the length of the data frame before it got deduped. When I mean dedupe, I mean like before duplication was removed, right? So it's first of all going to check the length of the data frame before and store it in a variable called before. Then it is now going to check the sum of duplicates in that data. That you will use the dot duplicated function to get the instances of duplicate records in a column. And if now to get like a number of how many of those duplicate records are present, you will now add the dot sum function, and it will give you a particular number that, oh, okay, there are 5 duplicated values, there are 2 duplicated values, and so on and so forth. So now, based on this, we introduce our conditional statement, and we say if dupes is greater than 0. So we are saying that if you've checked the sum of duplicated values and it is greater than 0, meaning we have duplicate value, then send us a log warning saying, oh, it found this particular number of duplicates, and it is going to remove the duplicates and keep the first value. I think the way duplication works, you can either set it to keep the first value it sees, or you can set it, I said, explained yesterday, if you have duplicates of id is equals to 2 on the first row, then you have that same id is equals to 2 on the fifth row. When you do a dedupe on that row, it is going to keep the first id is equals to 2, and it will take out the second id is equals to 2. So that's what it means by keep equals first parameter. So based on if the dupes is greater than 0, it is then going to apply the drop duplicates. So the drop duplicates function is going to take two main parameters: the subset, which is the column of the data frame you are working with. In this case, because we're working with a function, we are setting the column name to be column. So when we call out this function, we are going to impute the column of our choice. We are going to impute the column of our choice, right? So then we're also setting the standard parameter of keep equals to first. Now it is not saying that else if this doesn't have a duplicate, like meaning if dupes is not greater than 0, then to just print out no duplicates found. Then once it is done with this condition, it is then going to check the length of the data frame after. So it stores it in a variable called after. So that's all what our function is going to do. You see how it summed up multiple tags into one single line. So we'll just call it once and we will get our response. Okay. So let's try that right here. I remember our ID column is stored with capital ID. We are yet to convert the column name. So let's still type it out how it is. So if we remove duplicate CF sample, which is our data frame, the second parameter is a column which is our column that we imputed here. Then it gave us a warning because of our found one duplicate, and it's removing the duplicate and keeping the first value. So what is the info it's printed out? Say was 3. After the dedupe was 3. So this is a very interesting concept. So we're going to still delete this because we are doing everything at once, not one, right? So now we're just looking at all the functions we created before our single run. Now the next function we created to keep things day, and we use the fill now method. And I told you there are other methods to fill missing values aside the fill now. You can either do like a forward fill, you can do a backward fill. No, so not access the fill now, along with fill now, right? You can set a method to use a backward fill, forward fill, or you can use like an aggregate of a particular row to be able to work in your fill now. But in this case, we are just hard coding it and saying that wherever there's an empty value, let it just represent that value with this hard code. Whenever there's an empty row or there's any empty data, let it substitute it with this value. So this function is going to take in three parameters. The first parameter will be the data frame you're working on. The second parameter will be the field that may or may not have empty values. Then the third parameter will be what is the value you want to give when you find the empty value. So we should test this out with our, let's say with our email. As normal, when you're calling it using a function, just simply call out the name. So we are saying fill missing values. So what's the first value? Our df. What's our df? Remember we saved our df as df sample. That's the data frame we're working on. The second parameter is the column. Which column are we looking at to have empty value? I can see our email column is email. Now the third parameter is what is the value you're trying to pass. In this case, I will want all the empty values to be replaced with unknown. So as simple as this, if I should call this function, oh, I didn't close it, sorry. So if I should call this function, you can see now that instead of none, it has printed it out as unknown. So now we have all our empty values simply replaced with unknown, calling it out in one line. After the final function created here was to load to Postgres, because we already know that we have a standard connection. That let's just take it for example for this workflow. We have a standard connection to Postgres. I created the database for the sake of this class. So remember that I told you this is a standard form of doing your create engine. You add up the dialect, which in this case is Postgres database, plus the driver. The driver for Postgres database is CyclePG2. So then the next parameter is username, password, hosts, the ports, and the database. So once you use your create engine function to pass in all these values, you and store it in a variable called engine. This variable called engine is serving as the particular engine to connect to your database for it to be able to perform transactions in Python. Okay, so now that we have this, we are going to then we are going to input our try and accept block, right? So our try and accept block is going to try to convert our data frame into a topic, right? It's not just a topic. I saw a notification, sorry. We're going to convert our data frame into a table on our database. So the parameters this function is going to take is the data frame and the table name you want to create, right? Data frame and the table name you want to create. So if you should have your data frame, is going to convert that data frame, which is DF. So in this case, let me set up database so it will be up and running. Then we will see writing into the database. Okay, so we connected to a database. So now let us run this. Where's our workflow? Right here. So now let's run this function and see how it works. So if we call out the function name load to Postgres, so what does the function collect? The first parameter, data frame to load. The data frame to load to Postgres. In this case, we have our data frame which we called df underscore sample. Then what's the second parameter? It's going to take in the table name. In this case, the table name, we want to call it that on our database, we want the table to be called customers. So we're just going to call it as customers. We have to put that in string because it's not defined. So once we do this, you can already see the login. It's telling us, okay, it is the data table customers into Progress, and you can see data successfully loaded into database. Now let's go to database and see what we have. So hope you can see my screen. Okay, so we have our Apache and POSI database. So this is where we wrote our table customer. So this is actually a PG admin because it has like its workbench that you can use to write SQL to that database. In the case of Postgres, Postgres has its workbench called PG admin. It is through PG admin you can manage your data in your Postgres database. So that is this interface you are seeing right PG admin that we are using to manage the data in our PG admin to see the code, the data in your Postgres database. So just so you know, because I know that for short to Q2 SSMS is the same thing. Yes, SSMS is the code interface for SQL Server. For you to be able to manage the data in your database, which is the database was that their workbench again, something like that. The Oracle, I don't know if any of you are familiar with Oracle. Oracle database the ID is Toad. You can use Toad to manage your data in database. So I'm just saying this while our database loads because this is taking a long time. So while outside, it soon gets confusing. When they mention PG admin, it's just simply an interface for you to be able to manage data in database. But the actual database is Postgres, okay? So why is this thing not loading? And it was actually up and running before our class. So let me just reload the page and see what is going on. Okay. So this has loaded and let's see what we have. Remember we are looking for our customer table because we wrote our data frame into a table called customer. So that's what we are looking for. So now we've moved on to Patch and Posy. We've moved on to our Patch and Posy database. So now let's look for our table. The table will be in the schema. I really don't know why this is taking time, but it's actually working on my local system. It's not even is doing that. Let's build our workflow. So we'll get back to this. We're going to see then how it works. Like we're going to see the table in our database. Once the server comes up and it's up and running perfectly, we are going to look at that. So now the next thing we'll then do is we are going to now start our workflow. So in this case, our workflow would be we want to read from a CSV. Remember that we already created a CSV using our pandas data frame. We created a CSV and put that into a data frame, right? Using the pd.read_CSV, nothing serious. Then we are then going to clean the data, just simply calling out all. So in this case, remember all the functions we created to remove duplicates, the functions to to rename the column functions to rename values of them to work with our workflow. That's second stage of this workflow. So the first stage is to load the data. Second is cleaning the data. In this case, is like is doing something simple and it is not generic. It's very specific because how would you know the old name of the column that you want to rename, right? So if you are creating a function, you have to be very realistic and not have to rewrite any code. But you have to look at it that is it actually worth putting in a function? So I looked at that particular task and it wasn't worth putting in a function because the way it is structured, I would have to always put in the old value, then put in the new value, which in this case, the new name it needs to be transformed into. And before you type out all those things, you'd have seen that it is better writing as well to the function. The name of our column, which was spelled this way, then we named it new name, then put the parameter in true to ensure that the changes is being made on the data frame. Now the second task we did to standardize the column name. I explained to you what that was. So it is going to make it a lowercase uppercase. In this case, as simple as that. The next function in our transformation is to standardize the values. So we're going to convert the values to uppercase in this case, in this situation, and it is going to return everything in uppercase. Simple as that, with just one single line. Okay. Now the next value is function we call that is our remove duplicate function. So with everything that we set now, remove duplicate functions, we called it out with our data frame name, and we called it with some to use the dupe. You might not ask that why are we using df instead of df sample. That's because in this case we loaded our data frame with df instead of df sample. So I can easily just type and work with data frame instead of show you how it looks. Oh no, let's continue with our workflow. We'll look at that afterwards. Then the next step we did again, just like as we did yesterday, we converted missing values to unknown. So first thing first, we want to see, oh, okay, is there any missing value? So based on this, we use the isNav function. I remember I mentioned that the isNav function is a function that you use to check if there is any missing value. You're just asking Python, is there any missing value? So if there is, let's give it the sum of the missing value in that data frame. So now that okay, of the missing values is greater than 0, there is this number of missing values and it's going to fill it with unknown because that is what we're going to do. So based on that, we then call that the function to we then call that the function to we call that apply the missing values. And remember that when we created the function, we set it with 3 parameters. Let me show you again so it will be recorded. We set the function with 3 parameters. We have the data frame, the column, and the value. That the value wants to change the missing. That is how the data frame case is df. The column of what is email. What's the on this? We simply call that function, and this is automatically going to convert all the missing values to then convert data type. And with the way the function was created, it is not really very a single parameter. So based on that, we just use the dot apply function of Python to apply the function into our column, which is what we did right here. And remember, the function was to convert data type, right? So to convert in this case, I wanted our amount to. So if I even want to come back and add more tags or add more functions, I will just simply go to the functions I've defined and work on them. So I will not add all the tags and all the long workflow. I'll add it into the functions, then just simply call it out in my workflow. To keep things in your workflow is better than just writing the tags out every single time. So now transformation layer. Now the last time, remember, load to table name you want to call it on your Postgres DB. So in this case, what is data frame it is loading? It is loading DF. Then what is the table name? We want it to be called customers in our database. And we also made use of the try and except block. So if the code should fail, or if the code should crash, or if not, something is not correct, it will easily tell us, oh, it has tried it, but it didn't work, except bring the error that occurred. It wrapped up the logic in an error. That's the best way you'll be able to implement certain parameters that even when it crashes, it will be easy to debug and it will be easy to get it back on its feet. Okay, and as each of the cells are running, we are then going to see the output of our log. Okay, so it is very easy to do this here on Jupyter. It just comes to your run function, then we are going to run the selected cell and all below, so which is what we are doing here. So as you can see, it is running very fast. All our functions are created. Hold on. Why is it loading into the database? Sorry. Let me restart again. It didn't, the flow was not how I arranged it. One job, it started cleaning data. Then you can see for our duplicate checks, it checked for duplicates. It found one duplicate, removed the duplicates. You can see the number of rows we had before. We had 4 rows. Now, after we had 3, after removing the duplicated value. It also told us that we had one missing email, so we filled it with unknown. You can see the way it tells us clearly what exactly that we are doing because we implemented that. Now, the last step, it's it is telling us, okay, it is the pipeline succeeded successfully. It's printed out the message, ETL pipeline completed successful. It was successful, ETL pipeline completed. Based on this, let us customers table look like. So this is our database and the book. Let's view. Okay, sorry, let me share my database. I hope you're seeing the screen for the database. Or let us wait a bit for it to come up. Okay. So now based on this, let us view our data. We can view all the last time about 4 rows in this data frames. Not it won't crash any. Let's wait for a while for it to come up. We just give it time to load up the table because I believe there's a lot of tasks running on temps. Quite slow setup things. But just basically, so it's to be done soon. So while this is loading, code base will be shared. The code base will be shared for you to practice on your own. Actually, not to, it's not the matter of choice. You need to practice because we thought. Not just needed to have your quiz, you have your exercise, and everything is going to be from what we thought. So the code base will be released to you. It's released to you by my colleagues, and our actually employees and going beyond what is written there in the code base. Because the code base is just fundamentals. Everything here is just fundamentals, just to get you going and to let you know what exactly she expects. So you can actually be further on and build more on it. But yes, you actually practice that and you will get the code. Because today we will try to reiterate on any question, any specific question, or anything that you need specific clarification to. Now is the best time to drop it on the chat and learn it better. Okay, let me close off some of this. Hold on. Why is it sending this way? I would have to, so we will just have to queue this, and by start to take a long time. It's take a very, very long time to come up again because this is not actually not sustainable. But regardless, our customer have already been loaded. It has been loaded into this. But wait, we haven't gone too far. We are connected to database on our Python. So through Python, without looking at PGI, remember we have already connected to database through Python. So let us see how that goes. So we're going to write our query. Remember that our table is stored in customer now, right? So let us select all from customer. Is it customer or customers? Okay, customers. As simple as that. Then our query equals to where's my equals to sign. So now the next thing to do is to then use the df to SQL function. I don't want to rename our df. No, let's do customer to SQL function. So we're going to name it as SQL. So in this case, we'll be running our query and we'll be running it with our engine. Good. Oh, sorry, this will be pd.readsql. We are reading it this time. So customer is equals to pd.read underscore SQL. We have run. So engine is not defined. Okay. Oh, engine was defined in our function. It wasn't defined, and we're going to define it as an independent variable here. So let's define engine right here. Output in this data frame. That will let us know that our loading to the data to Postgres was successful. Okay. I guess the same translation data on Python. This is meant to have reading 1 minute later. So it's actually a server issue that will affect on both PG admin and affect on both Python IDE. And as you can see here, Jupyter is still telling that it's busy. So the result not, so we just keep holding on for this. Anyway, so I'll wait for that. Is there any question? Any question that needs any clarification on from anybody? Any question at all from any parts of the various classes we've had on Python? This is the best time to ask that, because after today, next week we'll be moving on to another tool, which will be the final tool in the fundamental tools of data engineering. We're looking at DBT. So we won't be coming back to Python next week. So today will be the perfect time to ask any pending questions or get any clarification on any topic that you might find a bit difficult. I would actually prefer to be able to ask questions back, because if the silence means there is no question, that means I can have the right to ask you questions based on the fact that you understand everything. So I'm going to speak with our coordinators and we will have a section where we will all come one on one before, maybe before our final exam, or maybe as grading of our workflow. So we will confirm that you really do understand based on the fact that no one is asking any question. Okay, so Unfortunately, server is not coming up, and my system is going to, if that's restarting to state, is going to take up our time in the class, because the purpose of this class was to go over the end workflow, applying everything we've gone through for the past few classes. And the fact that no one's asked any question, am in confidence that we really do understand everything that was being passed off of today. So based on that, we might have to come to the end of today's section. And I guess we would see, not I guess, we will definitely see again next week, Monday, when we're starting our new section on DBT. I'd have loved to start today, but I would actually like you to go back with this code base and practice and build more on what you learned. So next week we'll come in newly and start up a new topic, DBT, which is a data transformation tool. It's a very good tool used in modern days to transform data. So all this thing I'm writing here in Python, you will see how it will get integrated in DBT in modern day practice to perform transformation on large amounts of data. Okay. So thank you for your attention this evening, and do enjoy the rest of your evening.